titled Writing Equations for Quadratic Functions. We're going to be answering the question, let me make it a little bit bigger. There we go. What new connections can I make? So we're going to be doing pages 9 and 10. The first thing we need to do is to read page 10. So flip over to page 10, down at the bottom. You're going to notice that there's your math notes box. Okay? So the math notes box is titled Zero Product Property. And when the product of two or more factors is 0, one of those factors must be what? 0. So whenever you multiply by 0, you're always going to get 0. Okay? That's called the zero product property. Okay? Algebraically, it looks like this. If A times B is 0, then A is 0 or B is 0. For example, if you have 2x minus 3 times x plus 5 equals 0, then 2x minus 3 equals 0 or x plus 5 equals 0. Solving yields two solutions, 3 halves and negative 5. This property helps you to solve quadratic equations when the equation can be written as a product of factors. All right, if you have a highlighter, go ahead and highlight the words zero product property. If you don't have a highlighter, just go ahead and circle it, and then turn back over to page 9. So for question number 39, it says, this is table to equation, okay? So you know how to make a table for a quadratic function, but how can you write an equation when given the table? Make a table of quadratic functions, but how can you write an equation when given the table? Write an equation for each table below. What clues in the table help you determine the equation? Verify that your equations are correct. Okay, so for example or problem A, they give us this table right here. Instead of doing it vertically, they draw it here horizontally. So the x's are on the top, the x values are on the top, and the y values are on the bottom. So the other way they drew them is vertically, and then they'll have the x values on the left and the y values on the right. Okay? It's just the same, it's just turned. Okay? So what you want to do is you want to look for the pairs that have zeros in them. So I took my highlighter and I highlighted 2 points. I highlighted the point negative 3, 0 and the point 2, 0. Why did I highlight those 2 points? Because they both have 0 in them. That means when you graph them, they're going to be where? On the x-axis. Good. So they're going to be right on that x-axis. And because they're both part of a parabola, we know that parabolas also have a line of what? A line of symmetry. So between these 2 points, exactly in the middle of those 2 points, is going to be your line of symmetry. Okay? We can also take those 2 points and make binomials out of them. So one of them has x at negative 3, and one of them has x at positive 2. So we're going to come up with a binomial that'll be equal to 0. Why 0? Because we have that zero product property. One of them has to be 0, so we're going to assume that both of them are 0. Okay? So what number can you add to negative 3 to make it to 0? That would be positive 3. Okay? So if we took this negative 3 from right here and plugged it in right here, we would have negative 3 plus positive 3, and that would go to 0. Okay? Same thing with the 2. If we took this 2 and we subtract 2 from it, we get 0. And we would be able, this is the reverse of the zero product property. Okay, we have to figure out the opposite of these numbers and make them into our binomials. So if we have the factors x plus 3 and the factor x minus 2, we can take those two binomials and get our trinomial from it. Okay, so throwback to last chapter where we used our unit rectangle, and we multiply the x plus 3 times the x minus 2. Okay, then we're going to fill in all of our boxes here and write our trinomial. So x times x is x squared, 3 times x is 3x, x times negative 2 is negative 2x, and 3 times negative 2 is negative 6. You just multiply what's above it and to the left and fill in each of the boxes. Okay? Any questions on this part of it? All right. Now we're going to take our different terms and we're going to combine any like terms if we have any. So we have 1x squared, we put it there. We have a 3x and a minus 2x right there. And then we have the minus 6 right there. You look for any like terms. Only those two in the middle are like terms, so they combine to just get our 1x, and there's our trinomial. Okay? For part B, you're going to do the same thing when you get into your groups of 4. You're going to look for the zero terms. You're going to use the reverse of the zero product property to find out what the binomial should be. Then you're going to multiply them and write your answer as your trinomial. Okay? So we're going to skip that one for right now. You're going to do it when you get into your groups. Question number 40 says, Gwen is stuck while trying to write the equation for the quadratic function given in the following table. Her teammate Sadie says, this looks like part A of the problem we just did, except the y values are all doubled. Doubled just means what? What does doubled mean? Times 2. Everything's twice as big, right? How can that help us? So we're going to use Sadie's observation to help write the equation of the quadratic function given in the table below. So all of the numbers right here are just doubled of what we did right here. So if you take this 6 and you multiply it by 2, you get the 12, right? 0 times 2 is still just 0, but negative 4 times 2 is negative 8. Negative 6 times 2 is negative 12, and so on and so on. They're all just double, or what we're going to call 2 times. So we're going to still use the x plus 3 that we used in part A and the x minus 2 that we used up there in part A. We're just going to multiply all of it by 2. Okay? So we already know that this binomial multiplied out is x squared plus x minus 6. Check A if you can't remember. And then we're going to multiply it all by 2. So 2 times x squared is 2x squared. 2 times x is 2x. And 2 times negative 6 is negative 12. So if everything's doubled, you just multiply by 2. It's sort of a shortcut on that one. Okay? Any questions on number 40? Anybody still writing? A couple people? Okay. I'll pause just a second. All right, up at the top of page 10 is question number 41, which is called the water balloon contest revisited. Remember IMP's water balloon launch? Since the water balloon landed on the computer, you were given only table of data shown again below. Write an equation that represents the height of IMP's balloon as it traveled through the air. Okay? So remember, for IMP's information, it started giving us points, and then the computer got hit by water and the computer stopped working, right? So we want to see, can we get any information? We have a 0 here, but we don't have a 0 over there, right? We can count it out and figure it, or we can look for the line of symmetry, okay? How do I know this is where the line of symmetry is going to be? Because I have these two matched up. They're on opposite sides of the line of symmetry. I have these two lined up. They're on opposite sides of the symmetry. And this one's right in between them. Right? You guys all see that? If we keep going out this way, we're going to have 16. Then we're going to have 9. And then we're going to have 0, right? It will work its way to the middle. That makes this the line of symmetry, okay? You can figure out and count where the other 0 will be just by working your way out. And you can figure out, does this parabola open up or does it open down? You can tell me, does it open up or does it open down? So if we have a point at 7, 25, and then 6, 24, and 8, 24, the points are going this way. So it opens down, okay? Because it opens down, we need a negative sign out front, okay? So you're going to put a negative right there. Then you're also going to figure out where the zeros are at. One of them was given to you. We like this one, right? So it's at 2, which means that we need to take the opposite to make our binomial because of the 0 product property. So we've got x minus 2. And then we can figure out where the other one's at by going this direction, right? If it was 21, the next one would be 16, and then 9, and then 0. So that's 3 away. So if we take the 9 and we add 3 to it, where do we end up? 9, 10, 11, 12, right? Okay, so our other 0 would be at 12. Because of the 0 product property, we know that this must be x minus 12, because 12 minus 12 is 0, okay? Now we're going to multiply these two binomials together. So we can put x minus 2 here, x minus 12 there. X times x is x squared. X times negative 12 is 12x. X times negative 2 is negative 2x. And negative 2 times negative 12 is positive 24. So we write it as our trinomial, but we can't forget this negative sign because we determined this one opens down, right? So we have to multiply everything times negative 1. That makes this one negative. That's negative, so that becomes positive. And that one's positive, so it becomes negative. Basically, everything switches signs. All right?